Hi friends, I'm Arasi. Welcome to Groovy Mathematics. In our past videos, we saw the introduction of Vedic mathematics, then about the father of Vedic mathematics and the features of Vedic mathematics and its uses in and how it's implemented and what are the technologies which are being developed using the Vedic mathematics. And from this video, we are going to see the problems, how we can solve mathematical problems using Vedic mathematics. And the first method which we are going to see, do you like to know that? Yeah, it's nothing else than last totaling 10. And here, just see here, I'm going to give you below a problem and I just expect everyone to solve the below problem within 5 seconds without a pen and paper. Can you all try it out? See, the problem is 78 into 72. Is it possible to solve this problem without a pen and paper and within 5 seconds? Yeah, come on. We can do it. Yes, we can do it using a Vedic mathematics methodology. And in Vedic mathematics, initially I told you all that the Vedic mathematics, there is also formulas which is known as the sutra. So to solve the problem which I have given before, that is 78 into 72, to solve that problem, do we need sutras? Yes, obviously we need sutras. So come, let's first find out the sutras which are required to solve that problem. The sutras are Ekadikena Purvena. Two sutras are required, and the first sutra is Ekadikena Purvena. Ekadikena Purvena means by one more than one before. By one more than one before is Ekadikena Purvena. Okay, and the second sutra is Antayordasha ke Abhi, which means last totaling 10. Antayordasha ke api, which means last totaling 10. Okay, we are going to apply these sutras and we are going to solve 78 into 72 and the same numbers of the same pattern, and we are going to see some problems for this methodology. Come, let's start it. First, 78 into 72. What I'm going to do initially is I'm just going to divide this number into two halves. Here, if we analyze the pattern, see here, the last digits, it sum up to 10. Isn't it? Yes. The last digit is 8 plus 2, which is equal to 10. Now are you all able to get a sutra here? Yes, it's nothing else other than last totaling 10. And here, see here, the first digits are the same digits. The first number also has a 7 and the second number also has a 7. So this number is common. So we are going to apply this sutra for the numbers where the initial digits are the common and the last digits sum up to 10. For this kind of numbers, we are going to apply the sutras Ekadikena Purvena and the last totaling 10. Okay, to get the answer, I'm first initially splitting my answer into two parts. One is LHS and the other is RHS. To get the LHS, see, on LHS side, I'm having 7. So I'm going to operate this 7 and I'm going to get this LHS. The common number is 7. And here we are going to use the sutra Ekadikena Purvena. That is by one more than one before. If we take the common number 7 and Ekadikam, that is by one more of this 7 is nothing else 8. One more, that is I'm going to add a 1 to the previous number. The previous number here is 7. So I'm going to add 1 to the 7 and the answer is 8. Okay. To get the LHS, what I have to do is I have to multiply this common number. This is the 7 with the ekadika of that common number. That is the 8. And to get the RHS, see the last digits, it totals to 10. To get the RHS, what I have to do is I have to multiply these two digits. Just see here. The LHS here, the common number is 7 and the ekadika of 7 is 8. And to get the LHS, what I'm doing? I'm going to multiply the common number with the ekadika of common number, which is 7 into 8. So I'm getting 56. So my LHS is 56. And come to the RHS. The ending numbers are 8 and 2 and the sum of those numbers is 10. And I have to get the product of these two numbers as the RHS. So 8 into 2 is nothing but 16. So my RHS is 16. So now what I have to do is I have to just put the LHS and RHS side by side. I need not do any other operation over there. Just give the answers directly. So my 78 into 72 is nothing but 5616. That is 5616. You all got it? Okay. I'll again explain it with another problem. Come on, let's see. The next problem is 64 into 66. Come on, just try to solve it with me. Come on. First, initially what we have to do? We have to split the number. See the last digit. The last digit totals to 10. Isn't it? Yeah. The last digit totals to 10. And think of the first digit. Both the digits are common. The same digit. Both are 6. So my common digit is 6 here. And I'm now going to split my answer into two parts, LHS and RHS. To get the LHS, what I am going to consider? I am going to consider this common number, that is the 6. What is the ekadika of 6? Which is nothing else other than 7. So ekadika of 6 is I have to add 1 to this 6. Okay. So adding 1 to this 6 gives me 7. Okay. And how I'll be getting the RHS? RHS, for RHS, we have to multiply the digits which sum up to 10. So, for LHS, the common number is 6 and ekadika of common number is 7. So, my LHS is 6 into 7, which is equal to 42. Okay. And if we go for RHS, the numbers here, ending numbers of 4 and 6, which sum up to 10. It satisfies the condition for last totaling 10, isn't it? Yes. And if it satisfies the condition, the RHS is obtained by multiplying those two numbers. So my RHS is equal to 6 into 4, which is equal to 24. Okay. Now what I have to do? I have to just take the numbers directly below. So 64 into 66 is nothing else 42, 24. That is 64 into 66 is 4224. Okay. Or have you all got it? Okay. Okay. Now I'm going to go for my third problem. Till now we saw 2-digit number. Can we go for a 3-digit number? Yeah, it's 101 into 109. Yeah, see here. How I have to split the numbers here? How I have to check? It's very simple. The same thing. Go for the last digits. The last digit here is 9 and 1. Add it off. The total of 9 and 1 is, obviously it's 10. Is it 10? Yes, it's 10. So the total is 10. So I can apply the sutra last totaling 10. But another condition which we have to check here is the initial digit should be a common digit. I'm having 1, 0. What can we do here? can we take this as a single 10, single digit 10? Can we take it as a single number 10? Can we or not? Yeah, we are going to consider this not as a two-digit number but as a single number 10. Okay, so if we consider it as a 10, see here also the common number is 10, here also the number is 10. So both the numbers are common. So what we can go, can we apply the sutras now? Yes. Initially I have to divide my answers into two parts, that is the LHS and the RHS, isn't it? Yes. So for LHS, I have to first find the Ekadika of this 10. Ekadika of this 10 is 11. Okay. Okay. For my LHS, what I have to do? I have to then multiply this common number with the Ekadika of this number. The common number is 10 and Ekadika is 11. So multiplying it, what I get is 10 into 11, which is equal to 110. And if we come for RHS, see here, the ending numbers are 9 and 1. 1 plus 9 is equal to 10. So last totaling 10 sutra satisfies here. And so we get the RHS as 1 into 9, which is equal to 9. Okay, just a point to be noted here is, did anyone notice that in the previous problems, we were having two-digit answers in my RHS? Have anyone noticed in the previous problem? Yes, in RHS we will be having a two-digit answer, but here we are having only a single digit. Just remember, RHS should always be a two-digit number answer. It should never be a single digit. In last totaling 10 method for multiplication of numbers, the RHS should be of a two-digit number and it should never be a single digit. But here I am having only a single digit. How can I convert it into a two-digit number? Yes, we can convert it by adding a 0 before it. 9 is equal to 09, isn't it? Yes, I'm going to convert this 9 into 09. Okay, and see here. Let's first consider the numbers which gives the total 10. First 1 and 9, 2 and 8, 3 and 7, 4 and 6, 5 and 5. These numbers on totaling will give the total 10. Okay, but now if we multiply these numbers, see here, 2 8s are, you will be getting 16. 3 7s are 21 and 4 6 are 24 and 5 5s are 25. Okay, and see here, 1 and 9 is 9. Only for 1 and 9 you will be getting this issue. In this place you have to add a 0 before the 9. This is a very important thing. We should never forget to add a 0 before the 9. If we forget to add the 0 before the 9 and if we forget to make the 9 as a double digit number, then our answer will be wrong. Just see here, 101 into 109. I am going to write the RHS and LHS directly and my answer is 11,009. If I forget to add that 0 over there, what we will be doing? We will be just writing 110 down and 9 down and the answer would be 1109. Is it a correct answer? No, it's a wrong answer. 11,009 is completely different from 1,109, isn't it? Yeah, 0 before a number doesn't have value. So we can add 0 before that number. But RHS is the continuity of this LHS. The RHS, the value of RHS is the continuity of the value of the LHS. So the place value of 0, which is in between some numbers defines the value of that number, isn't it? So it is very important to remember that in when we are getting 1 and 9 and the initial digits to be the common, the last digits to be 1 and 9, and if we are going to apply the last totaling sum 10 method, then we have to add a 0 before the 9 in the RHS. This is a mandatory thing. Please don't forget it. Okay. It is very, very, very important. So only I am repeating it again. If you forget that 0, the answer will be wrong. So the 0 has the value. Only for a number before a 0 before a number doesn't have a value. But this RHS is the continuity of the LHS. It is not the individual number. We are splitting the answer to be a two parts, LHS and RHS. So RHS is the continuity of the LHS. So this 0 is much mandatory. Okay. Please don't forget it. Okay. Till now, we saw some multiplication problems. Can we see some numbers ending with 5? Yeah, come. Can we find the value of 95 square? Do you think it's different or it's difficult? No, we are going to apply the same method. Can we take this 95 square as 95 into 95? Isn't it? 95 square is 95 into 95. Can we consider it as the same? Okay. In this way, if we solve this problem, what we will be getting? The same method. Last digits totaling to 10 and the initial digit is the common. Isn't it? The last digit total to be 10 and the initial digits are common. So now what we can do? We can again the same way. I am going to split my answer into two parts, LHS and RHS. For my LHS, what I have to do? I have to take the initial number. The initial number is 9. I am going to take the initial number and the ekadika of initial number is nothing else other than 9 plus 1 is equal to 10. Okay. Okay, I am getting 10 here. And for RHS, it's 5 into 5. The numbers total into 5 is 5 plus 5 is 10. So RHS is equal to 5 into 5. For avoiding it, what we can do? We can directly take it as 5 square. Isn't it? Am I correct? Come on, we can see. Initial digit is 9, isn't it? Yes, initial digit is 9 and ekadika of 9 is 10. Yeah, and my LHS is initial digit into ekadika of that initial digit. Okay, so my answer is 9 into 10 equal to 90. My LHS is 90. For my RHS, what I am doing? I am multiplying 5 twice, which is 25, which is equal to 5 square, isn't it? 25 is nothing other than it is the 5 square. Yeah. So whenever you are going to find a square of a number ending with 5, you can directly take your RHS as 25. Your RHS will always be 25 whenever you are going to solve a number which is ending with 5. Okay, you understood? Yes, okay. And here in this problem, 95 square is equal to 9025, which is 9025. Okay, okay. Come on, let's solve another one problem of the same method. 115 square. 115 square. 115 square, how we can split it here? We can split the answers into two parts and the numbers also into two parts. The 5 square different and 5 is different and the initial number I can consider the 11 as my initial number. Isn't it? For my LHS, what I have to do? The initial digit here is 11 and my ekadika of this initial digit is 11 plus 1 is equal to 12. Okay, am I correct? Am I correct here? Yeah. Okay, initial digit is 11 and ekadika of initial digit is 12. To get the LHS, what I have to do? I have to multiply this initial digit with my ekadika of the initial digit, which is equal to 11 into 12, which is equal to 132. Okay, for RHS, you can directly go for 25. As for any number squares ending with 5, the RHS is 25. But again, if you want to solve it the same way, the ending number is 5. So 5 plus 5 is 10. RHS is equal to product of the numbers 5 into 5 is equal to 25. Okay. Okay. Then my answer is 130 to 25. I can directly write the LHS and RHS below. So my 115 square is 13,225. Okay. Is my answer correct? Yeah, come on. Now just tell me, can you all solve this problem much faster than me? Just try it out. How you can practice yourself. You just prepare your own questions. You just don't learn the questions. Prepare your own question. First, initially understand the concept. How to prepare the question for this method. The first initial thing what you have to consider before considering preparing the question is the initial part of the sum should be the same number, should be the common digits, and the last digit should total up to 10. Okay, you should not change the value. The initial digit should be the same and the last digit should total to 10. If we consider this type of problem, this methodology, to solve using this methodology, you have to frame your questions like this. I'll give you some examples. 11 into 19, 22 into 28, 34 into 36, 43 into 47, the same way. 55 square, 65 square, 205 square. 205 square. How we can solve it? The same. RHS is 5 square, so it's 25. And LHS is 20 into 21, which is 420. Yeah, it's 420. So my answer is 42,025. The same way you too can solve the problems, but keep on trying it. Whenever you frame your own questions and whenever you solve it by yourself, you will be having a clear knowledge of your concept. If I can give you some questions, I can expect you to solve it and try it out, but you may not be able to understand the concept. You will be able to understand the concept one and only one you frame the question. So just frame your questions and practice it, and it will lead to a very great place. And you can solve these problems just by saying without a paper and pen, and not even within 2 seconds. You won't need a time of even 2 seconds to solve this kind of problem. Okay? If you are practicing well, you can achieve it. And thank you. Whatever may be the doubt you are having, please comment it in the comment box and I'll give the reply in the comment box. And please subscribe my channel, and whatever may be the comments, please share your comments. Thank you very much.